Hello, this is Roberto and this is the HVAC is my channel. Today we're going to be talking about heat load calculation, internal loads, lights. An example. Alright, so let's get into it. So we're going to take into account a conference room. So for example, let's put in here a conference room. Okay. Conference room. So for a conference room, usually what we have is, let's put it here, a table. Okay, and we're gonna put some seats. 1, 2, 3. Okay, 4, 5. Okay, 6, 7, 8. All right, so that's gonna be a conference room. Right there we go. All right, so to begin with, we want to obtain the internal loads. So for internal loads, as we were mentioning in previous videos, we have people, we have lights, and then also forgive me for the redundancy, but this is always very important. Okay, system and equipment. Okay, so people, lights, and equipment not yet. So for people, the number of people, as you can see, it's 8. But we need to find out what about the lights. Okay, so for lights, as we saw in the previous video, we have the lighting power density. So we're going to put that in purple. So we need to obtain the lighting power density, and the lighting power density actually depends on the location. So step number 1, let's gonna get the location based on the location. Assuming that we are in Washington DC, okay, we put in here DC. So if you go to the international mechanical codes and everything, so we went to the tables in the previous videos, we found out that the lighting power density is actually equal to 1.1 watts per square feet. There we go. And where do you have that? You have that in the table on this side, right? So if we go here, conference room, see, conference meeting multipurpose room, you have 1.1 lighting power density, watts per square feet. Okay, so based on that, so what you have to do is do a quick calculation. 1.1 watts per square feet. Okay, so what we forgot in here to put is that also the architect is going to provide with how big is this conference room. That's for sure. Okay, so this is going to be for 300 square feet. Okay, so based on that, what we have is times 300 square feet. All right, so this goes away. So what we have, so for lighting we have 1.1 times 300, so that's actually equal to, let's put it here, equal to 320 watts. All right, okay, but at the same time you want to find out this in BTUs per hour, right? So technically you have 300 watts times, okay, 1 watt, 3.41 BTUs per hour. Okay, so watts go away, and this is going to be equal to 300 times 3.41. That's going to give me a total value of 1023 BTUs per hour. There we go. All right, there we go. We have that. And usually, so if you have a building, you're gonna have so many spaces. You're gonna have like say 50 or maybe 20 types of spaces, and it's very interesting. It's very important to make an Excel table, so that way you can all have this automated, so you don't have to be doing this one by one. You just could put a formula and then you can obtain this lighting load. So we're gonna put in here lighting load. Lighting equals to 1023 BTUs per hour. So that's why the lighting power density is very important, because as you remember, we were checking on other locations. For example, say that also in this video we also teach you about the design aspect because I also have worked with other engineers that they love being conservative, and they say, like, for example, in DC, in DC, they have the energy code 2017, but this is based and amended by IECC, IECC 2015, right? So sometimes they rather use the IECC 2015, which says that the lighting power density equals to the following. So equals to 1.23, as we saw on the previous video, per square feet, right? So in that case, what we're gonna have is the following: 1.23 watts per square feet. And what is our square footage? It's 300 square feet. And then square feet with square feet goes away. This is gonna be equal to what? So we're gonna put 1.23 times 300. That's 369. 369 watts. Okay. Now 369 watts, I'm going to convert this to BTUs per hour. 1 watt, 3.41 BTUs per hour. And then watts with watts go away. And then this is going to give me what? 369 times 3.41. So that's going to give me a total of 1258.29 BTUs per hour. Okay, so my lighting load, my lighting load equals to 1258.29 BTUs per hour. And even I'm gonna put another type of design in here. So we put in yellow. In New York City, for example, our lighting power density was equal to what? 0.93 watts per square feet for conferences rooms. So in this case, you're gonna have less. So that's the part that HVAC is in my channel comes very handy, because I'm trying to show you the design aspect of this. So you have two choices. If you're in Washington DC, you can take into account this LPD based on the DC energy code, which is appropriate because it's the energy code that the DC wrote, right? So 1.10 watts per square feet. So you have this load. However, if you want to be very, very conservative and be still within kind of code, you can use the IECC 2015, and as you can see, this is a more conservative approach. See, 1258. We're only talking about one space though, but if you multiply this conservative approach times a lot of spaces, so they are safe in the heat load. However, sometimes that when you oversize the system, that comes with you have so it's more expensive, right? So it's always a trade-off. So in my case, I would do this personally, but sometimes if you want to be safe, conservative, you can also do this, right? So I hope you enjoyed this video, and if you did, hit the like button and subscribe, and in the next video we're going to be making more examples about heat load calculation. All right, thank you so much.